Okay, so let's look at 3.3, number 30, which says we need to suppose that we know that the 3 by 4 matrix A has a solution. Okay, so I have A, which is 3 by 4, and I know that it has a vector S that's 2, 3, 1, 0 as the only special solution to AX equals 0. Okay, now that's not really quite what I wrote here, right? I wrote this as the only solution. What's the distinction? The book says it's the only special solution, and I kind of abbreviated that. Is that appropriate or inappropriate? Am I insane for having done that?
I mean,
What else solves that equation for certain?
the zero vector?
Yeah, absolutely. The zero vector has to solve that equation. So, what do they mean it's the only special solution?
The only non-zero vector?
Is that true?
Well, what it means is it means that that particular solution, actually, it's essentially that solution and any linear combination of that solution is zero.
That's what I want. So, this thing forms a basis for what space?
The null space.
The null space. So what they're telling me is that the null space of my matrix A is actually the span of that single vector 2, 3, 1, 0. You guys with me on that distinction? Okay. Alright. So that's just untangling what they told me already, right? Alright. So then they're saying, what's the rank of A and the complete solution to AX equals 0? What do they mean? Where's your picture? What picture are you looking at for this? Okay. Look at the picture on the front of the book.
Oh,
This one. Right? If there's one thing about this class, it's that everything about this class is on the cover of the book.
I have
So, I need to, oh, you need to peel that sticker off, dude. You gotta be able to see the cover. What are you doing? So, I need my cover of my book. So, here, abbreviated version of cover of book. And once again, I'm notably making these two different sizes and those two the same sizes. I have my matrix A here. This actually is going to double as a nice 4 subspaces review, right? Okay, so I know my matrix A is how big?
a 3 by 4.
It's 3 by 4. What does that mean?
It maps R4 to R3.
Good. So this space over here is R4. This space over here is R3. Okay. What else did they tell me? They told me that thing was the only special solution, right? So this space here is actually how big?
One-dimensional.
Good. This is one-dimensional. So really what I should do, right, is I should, instead of rendering it as two-dimensional, I should render it as actually one-dimensional. You see that? This box then has to be how many dimensional? 3. Does that make sense? Because the two boxes, right, are perpendicular and they add up to all of your domain space. So between the two of those boxes, they make up R4. That means I've got one is 3-dimensional and one is 1-dimensional. I'm going to have a hard time drawing these perpendicular, so I'm just going to do this. I'm going to make a cube out of this thing. Well, prism-ish, right? Right, so that's my 3-dimensional space. And then I'm going to put a vector out here, and I'm going to put right angles in all of these, and that one's going to be awkward. You guys with me on that? So this line is perpendicular to everything about that box. How do I know that?
Because the null space and the null space are always perpendicular.
the null space and the row space are perpendicular, so this is your row space, right? So this is my null space, and it's one-dimensional. This is my row space, and it's three-dimensional. Okay, does that answer the question they asked me, which is, what is the rank of the matrix A?
So, rank was,
Say that again?
Would it be 3 rank?
Yeah, it's rank 3. Okay, so part A. Rank of A is 3. Okay, then they're asking me also, what's the complete solution to AX equals 0?
oh, so this is x particular and x homogeneous.
Yeah, so what's the homogeneous solution?
The span of that vector.
Here. So it looks like some scalar A times your vector 2, 3, 1, 0. You see that? And then what's the particular? Well, they didn't tell me about a B to hit, right?
Yeah.
You guys see that? So I don't have an other side of this. I'm only solving the homogeneous version, which is when I set it equal to 0, right? You on board? Okay, that's A. C, how do you know AX equals B can be solved for all B? That's a weird claim. So their claim is that AX equals B can always be solved. Why is that true in this case?
It's true because the column space spans all of R3, and that's all the elements. All of these have to be in R3.
Do you guys hear that? He said the column space spans all of R3. So one, how do I know that?
The row space does.
Good. The row space and the column space have to be the same size, right?
Yes.
Which means that this picture doesn't look like this, right? This picture actually looks like another box, right? Of the same size. You'll have to forgive I didn't quite make it the same size, right? So that's my column space. And then there's one vector down here, the 0 vector in the corner. And that's the null space of A transpose, right? That's our fourth subspace. It's just the 0 vector by itself.
Yeah.
You guys see that? So, I know this, right? Or we call it an argument because it's not really quite a proof, right? My argument is that the rank of A is 3. And that's the dimension of the column space, right? And the column space is the range. You guys see that? So R3 is the range of A. And that means I'll be able to back out of whatever solution, right? Another way to say that would be to say, and we know that the matrix A is 1 to 1 between the row space and the column space, right? So we could exploit that. Rosie is ostentatiously bored by the rest of this explanation. Are you guys also ostentatiously bored? No? Are you good with this explanation?
I think so, yeah.
Okay, that's all they asked me for.
Yeah.
So I'm done.
I was really overthinking this then. Okay.
Yeah, really, when you've got a matrix, one of the first things you can do is try to write down as much of the picture on the front of the book as you know. That's never going to be harmful. Right? Might not help you in all cases, but it's always going to help you organize your thoughts a little bit. You can at least know which size of thing am I mapping where, which is a good start to solving any of the problems in